Assalamualaikum students. Now we are starting the next topic of the electrolysis, and that is electrolysis of molten and aqueous solutions, right? What we did previously, we did that what is electrolysis? The decomposition of an electrolyte, which is molten or aqueous by the passage of current. And when you pass current, the electrons, they are lost by the anions and they are gained by the cation. They come to the external circuit. Okay, I'm going to revise and then we are going to switch to the next topic, which is the topic of today. But first, let me share my screen. Yes. And okay. Yes, this is these are our notes. Okay, now coming to this. Storage. Now, what we did previously, what is electrolysis? It's a decomposition of an electrolyte by the passage of current. And what is electrolyte? This thing, that substance that conducts electricity in molten or aqueous due to freely moving ions. It decomposes when current is passed. This is your electrolytic cell. This is your cathode connected to the negative, anode connected to this. The electrolyte is either molten or aqueous, containing freely moving ions. The anions, they lose electron. The electron goes to the external circuit from anode to cathode, and they are gained by the cation. So, cation at cathode, anion at anode. Okay. This is cat and this is cat. Cation at cathode, anion at anode. Now, electrodes. What are the two properties of the electrode? Properties of the electrode, they must be unreactive and they must conduct electricity. So what are the examples? Graphite and platinum. And then the cations. The cations move toward cathode and they gain electron, they get reduced. Whatever is the charge, they gain that much number of electron. So plus 1 electron metal, plus 2 electron metal, plus 3 electron metal. But if you go to hydrogen, each H plus gain 1 electron making H, another H plus gain another electron making H2, sorry, H. So overall 2H plus, overall 2 electron making what? H2, colorless gas. It's written above, explained above, and written here. So whatever is the metal, it gains that much number of electron. It gains the number of electron equal to its charge. It becomes the metal which deposits at cathode. And if it is hydrogen, then it would be hydrogen gas, bubbles of colorless gas. Now, if we go to anion, it's exactly the same way, like hydrogen. Lose 1 electron, lose 1 electron, so 2H, F negative, 2 electron, and F2. 2 chloride, 2 electron, and Cl2. But if it comes to oxygen, then it's negative 2, lose 2 electron, negative 2, lose 2 electron. So 2 oxide, lose 4 electron, making what? O2. Right? This is repeated again. Now, electrolysis of molten. Like we have two types of electrolyte. We have two types of electrolyte, or we can say we have two cases. Two cases. What are the two cases? Number one, electrolysis of molten electrolyte and electrolysis of aqueous electrolyte, now molten. A. A. Molten. For example, if I have the same molten sodium chloride. First, I was thinking of aluminium oxide, but first we will do for sodium chloride. Now, this is your cell. This is anode. This is cathode. If this is molten, molten means melted. There is just Na plus, and the other thing is what? Chloride. And you can even find them in this electrochemical series. Na plus and chloride. Mostly your cation and anion are from these two series for cations and anions. So one is Na plus ions and chloride ion. This is positive, this is negative. So, and the electrodes are made up of what? Either graphite or platinum. So what will happen? Na plus will go where? It will go to cathode. Chloride will go to anode. Now, as you know, there should be the reaction. So what is the reaction at cathode? Reaction at cathode. Na plus gain electron, making what? Sodium. Right? And reaction at anode. How many chloride? Definitely 2 chloride will lose 2 electron, Cl2. So what is your observation? Silver colored metal at cathode. At cathode. Even you can say that below cathode, because if the metal, if the temperature is so high, this high temperature, the metal form, it will not deposit, it will accumulate below the cathode. Like it will fall down and it is accumulated here. Like the sodium metal, it would be accumulated below. Why? The temperature is so high that the sodium metal formed is liquid. So it will not stick to the cathode. It will fall down. Like it is melted. In the beginning, it is liquid. And with the passage of time, when it will cool down, it becomes solid. Right? So silver colored metal at cathode. What about chlorine? It's green yellow gas. It's green yellow gas at anode. So the chloride will go out, the Na will go out, no NaCl is left. So what happens to the electrolyte? It gets decomposed. What? The chloride will go in the form of chlorine gas. This is sodium. The electrolyte is fully decomposed, nothing left. Fully decomposed, nothing left. Nothing left. Right? So, at the end, one thing which is not usually asked, then what is the overall reaction? What is the overall? Look, it gains, it loses. In chemistry, we say that number of electron lost must be equal to number of electron gained. This point is asked only a few times. Like they just ask for the what is the reaction at cathode, what is the reaction at anode, the thing that I'm doing right now. Most of the time your question is that what is the reaction at cathode, what is the reaction at anode, what are your observation, write the half equation. These are called half equation, the what we have written at cathode and anode. Now the overall equation in which the number of electron lost must be equal to electrons gained, this is asked only a few times. But yes, we can't say that this is not in the course. It is in the course, but not tested too much. So number of electron lost must be equal to number of electron gained. So if we look at the equation, Na plus gain electron becomes what? Na. And the other is what? 2Cl negative lose 2 electron plus Cl2. Now, what you are supposed to do? Multiply this with 2. Like this is 1. If I multiply this with 1, nothing will happen. Multiply, like the electrons of this are multiplied with this to become equal, and the electrons of this are multiplied with this to become equal. This is 1. So even if I multiply, no change. So if I multiply this with 2, it becomes what? 2Na plus 2 electron and 2Na. Look, you will multiply this with 1, with 1. You will not multiply with charge. No, nothing. 2 with 1. Right? Now, what is your next step? These are all your reactant. These are all your products. Okay. Draw this line and put the arrow. Is there anything that is same between the all reactant, all product? It's Na plus. It's Na. They're not the same. They're different. But the electrons are same. Can we cancel the electron? Yes. 2 electrons. 2 electrons. So what is left? 2Na plus, 2 chloride, 2 Na and Cl2. The NaCl decompose to sodium metal and chlorine. The electrolyte is used up. The electrolyte is used up. Nothing left. Do you get? Now, another example. Molten. Molten what? Lead bromide. What I'm doing? I want to draw it. Okay, I will draw it again. This is positive, this is negative. Huh? What are the ions in lead bromide? PbBr2. So PbBr. What is the Pb? Pb2 plus. What is Br? Br negative. We know the equation. Pb2 plus will gain 2 electron and Br negative will lose 2 electron, making Br2. Huh? Like everything is the same. Just apply it. There are lead ions. There are bromide ions. The lead will go to cathode, gain electron. Anion will go to anode. This is anode. This is cathode. So 2Br negative will lose 2 electron, making bromine, and 2, not 2, 1 Pb2 plus. Pb2 plus will gain 2 electron, making lead. So what is your observation? Orange vapors. at anode, metallic deposits at or below cathode, and they are all what? Used up. Used up. Finished. Nothing left. So if I make the overall equation, 2 bromide lose 2 electron, Br2, and Pb2 plus gain 2 electron. Pb, are the electrons same? Yes. It's losing 2, it's gaining 2, no need to multiply. And what is your next step? The electrons are cancelled. Draw the arrow. On this side, these two are present. On this side, these two are present. So what is left? Pb2 plus into bromide turning into Pb plus Br2. That's it. Your next topic, aqueous electrolyte. What? Aqueous electrolyte, B case. Aqueous electrolyte. When it is aqueous, there's an electrolyte which contain a cation and anion, right? And there is water, aqueous, which is providing what? H plus and OH. From water, what are coming? 1H plus and 1OH. So, in the electrolytic cell, we will be having two types of cations and two types of anion, right? What? Two types of cation. Wait. Okay. So there are two types of There are two types of cations. There are two types of anions in the cell. Look, this is your cell. If I make it, wait a minute. This is the cell. Okay, it's a bit tilted. This is cathode, anode, and now this is what? The longer one is always anode. This is cathode. Now we will be having a cation, NH plus, and anion, NOH. We have two types of cations. Both will go to cathode. Both go to cathode. These both go to anode. Both go to anode, but only one will lose electron. This is called, this is called what? This is called, wait, this is called preferential. This is called preferential discharge. Both will go to cathode and both will go to anode. At anode, both will go, but only one will lose. This is called what? Preferential discharge. Both will go to cathode, but only what? One will what? Gain electron. This is called what? This is called preferential discharge. Like one is preferred to come out of the solution with either lose or gain. This is called preferential discharge. This depends. This depends. Wait, I think I should write it like this. It will be easy. The preferential discharge of anion or cation depends on their reactivity. On their reactivity, depends on their reactivity, which can be. This preferential discharge depends on their reactivity, which can be found from their position and reactivity series. The preferential discharge of the cation and of the anion depends on their reactivity, which can be found from their position in the reactivity series. How? Look. This is the reactivity series of cation. Now, keep in mind that for cation, in case of cations, the lower ion, the lower ion in reactivity series, in case of cation, only cation, the lower ion in the reactivity series is more reactive. So, the lower ion will gain electron when electrolysis, dilute or concentrated, whatever, right? The lower ion will always gain electron. The lower ion will always gain electron. In case of dilute, concentrated, aqueous, whatever is written, whatever, the lower ion will gain electron. So, if there is a competition between K plus and H plus, so which one will gain electron? H plus. Competition between magnesium and H plus, H plus. Zinc and H plus, H plus. Silver and H plus, silver. Always the lower ion. But if it comes to anion, it's a bit different. In case of anions. Now, what are the anions? Fluoride, sulfate, nitrate, chloride, bromide, iodide, and hydroxide. Now, fluoride, sulfate, nitrate. In aqueous solution, dilute or concentrated, these ions never lose electron in the presence of hydroxide. If these three are hydroxide, it is always hydroxide which will lose electron. It is always hydroxide that lose electron. So these three never. But if it is concentrated, then you know what will lose electron? Chloride, bromide, iodide. The chloride, the bromide, and the iodide, these three will lose electron if the question says that the electrolyte is concentrated. But if it is dilute, then it is always OH that lose electron, right? Now we are going to apply this. How? I'm going to, these are quite simple. Even this one is simple. I'm going to the mixed situation where we will deal every type of situation, molten, dilute, and concentrated. Like I want to go for molten, dilute, and concentrated so that you can get the concept of all. This you can do on your own. They're easy. So question number 19 to 23. Hmm. This one. 21. This is 20 and 21. I'm going to do these two questions with you, right? One is question 20. Copy. So what is the first case? It's molten lead bromide. They have given you the molten lead bromide. The change at the negative, the change at the positive used up. Now, they have explained what? One, the first line has been completed. We are supposed to complete for this, 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 and this. But now coming to molten lead bromide. Now, one thing, what they've written? 2. What is the meaning of this? The lead is plus 2. Molten lead bromide. So, lead is Pb. The ions are what? Look, the ions are, if I make a smaller one, this is what? Wait. This is what? Lead ions, Pb2 plus, bromide is minus. We did in the notes before this. This is positive, this is negative. Lead will move to this, bromide will go there. So at negative, the Pb2 plus gain 2 electron. And what is formed? Lead is formed. And the bromide will go to the positive. 2 bromide lose 2 electron, making what? Br2. So all these are used up. What they have written? Used up. When they say used up, this means your electrolyte is what? Your electrolyte is molten. It is what? Molten. So it's molten potassium iodide. Look, it's potassium metal. The potassium is formed from potassium ion. The iodine is formed when 2 iodide lose 2 electron, making iodine. So it was what? Molten potassium iodide. Potassium iodide. Now, next, it's dilute aqueous sodium chloride. It's dilute aqueous sodium chloride. Look, now I'm going to apply it. If it is these are your, you know what I'm going to do now? I'm going to draw this some 3 times. Why? Because I have the other 3 examples. So, you know, I'm going to do this way. Now, what is there? Dilute aqueous. From aqueous, H plus OH. From sodium chloride, Na plus and chloride. So there is Na plus chloride H plus OH negative. What we have? We have Na plus chloride H plus OH, and it is dilute. Now, can you tell me among Na plus H plus, these both will go to cathode? Both will go, but only one will gain. And which one is going to gain among these two and dilute? Among Na plus and H plus, the lower ion will always gain. Which one is the lower? Hydrogen. So among Na plus and H plus, which one? It is H plus. So here which reaction will occur? The 2H plus gain 2 electron and a hydrogen gas. Bubbles of colorless gas at cathode. Add negative. Hydrogen will form. Hydrogen formed. Right? Look. Bubbles of colorless gas among Na plus H plus. Which one is lower? In cation, in cations, which ion will gain electron first? Whether it is dilute, concentrated, aqueous, whatever is written, you have to focus on that which cation, Na plus, H plus, H plus. It's lower, it's more reactive. H plus is more reactive. Therefore, H plus will gain electron in bubbles of colorless gas, Na plus left behind. Now, among chloride and OH, what is written? Dilute. If it is dilute, now chloride and OH, in dilute, which one? Hmm? Chloride will lose if the question says that the electrolyte is concentrated. These three are only possible if what is written concentrated. And this one is when it is dilute. So if there is a competition between chloride and OH, if the question says dilute, then OH. But if the question says concentrated, then chloride. So which one? Definitely among chloride and OH in dilute, it is the OH. So 4OH negative lose 4 electron to water and oxygen. Listen, listen. The OH will go, right? The chloride is not going. The OH, the oxygen gas is formed. We will not write water. Why? Because it was already there. So what is the new thing that is formed? Oxygen. Oxygen is formed. What is formed? Oxygen, bubbles of colorless gas. Now, it was already dilute with H and OH. But if the H and OH, if they are discharged, what happens? If H and OH discharged, if HOH discharged, water discharge, electrolyte is getting what? Concentrated. Water is lower down. Electrolyte is getting what? Concentrated. Electrolyte is getting concentrated. Change to electrolyte, huh? Electrolyte, even you can say dilute NaCl become concentrated. Now aqueous copper 2 sulfate. Aqueous copper 2 sulfate. Come to this. Copper 2 sulfate aqueous. What is the color of copper 2 sulfate? It's a blue solution. You know why it is blue? This whole solution is blue. You know why it is blue? You know it is blue. Blue as copper ions are present in water. If there are copper ions in water, it's blue. If the copper ions lower down, their concentration decrease, the solution will turn from blue to colorless. Why? It was blue because of copper ions, but if there is no copper ions, would it be blue or it will change from blue to colorless? So it is blue as copper ions are present, but what is happening with the passage of time? The copper and H plus are cations. Copper and H plus. So among these two, which one? The lower ion will gain electron. So which one is the lower? Copper. So what is happening? Both will go to cathode. Both will go, but copper ions gain electron making copper metal. Huh? This is pink brown metal. Pink brown metal deposit at cathode. You know what happened? The copper formed will deposit like this. Pink brown metallic deposit. And the concentration lower down, its concentration decrease. When it decreases, would the solution be blue or it will change from blue to colorless? Solution will turn blue to colorless. Now tell me, repeat again. Among copper and H plus, these are two cations, both will go to cathode, but between the two, which one is more reactive? Copper. From where do you know this? Reactivity series. Copper is below hydrogen in the reactivity series. At this place, copper is below hydrogen in the reactivity series. So which one is more reactive? Copper ions. So what copper ions will do? The copper ions will gain electron and the copper ions will deposit. So pink brown, so not copper ions will deposit. The copper ion will gain electron, they make the metal deposit. And the copper ion decreases, solution will turn from blue to colorless. Now, next, what about? So it is not blue, it will turn blue to colorless with the passage of time. Next, sulfate and OH. Both will go. But among sulfate and OH, which one? Among sulfate and OH, the sulfate never lose electron in the presence of OH. So it's always OH that will lose electron in case of sulfate. So it's OH that will lose. So if it is OH, what is the reaction? What is the reaction? 4OH 4OH negative lose 4 electron to water and oxygen gas. So oxygen gas bubbles off colorless gas. If we look at the ions, there is copper ions, sulfate ions, copper sulfate, aqueous. Among copper and H plus, the copper is going out, pink brown metallic deposit, sulfate and OH. OH are going, oxygen gas far. So at negative, at positive electrode, oxygen at negative, oxygen at negative, copper formed. What is left? What is left? Sulfuric acid. Electrolyte changes from copper sulfate to what? H2SO4, acidic. Do you get? Now, next example. I hope you understand this. So what is your observation in this? Bubbles of colorless gas, pink brown metallic deposit, blue solution turn colorless, the copper ions decrease, blue to colorless, pink brown metallic deposits, and bubbles of colorless gas. Now, what about this one? If you look at the, what should be the electrolyte? How hydrogen is formed? H2 is formed from 2H plus gain 2 electron. How bromine is formed? 2 bromide, lose 2 electron and Br2. And what is there? This potassium hydroxide. So if I combine all these, huh? There is K plus, there is H plus, there is bromide, and there are OH. So what was that? Huh? This is actually aqueous potassium bromide. But if it is aqueous potassium bromide, among K plus H plus, which one? H plus, why? Among K plus and H plus, why H plus? The question is, because K plus is above and H plus is below, H plus is more reactive. Among bromide and OH, why bromide will lose? Why bromide will lose? Why not OH? Because the bromide is more concentrated. So this clear cut indicate that your electrolyte is what? Concentrated aqueous potassium bromide. Do you understand? Like the point is that, for example, if I have aqueous potassium nitrate, there is H plus and OH. Among K plus H plus, H plus is below in the reactivity series. Nitrate and OH. Nitrate never lose electrons, so it's OH. It's OH. So what is left? The H and OH, the electrolyte is getting concentrated. Electrolyte is getting concentrated. Now, suppose I have dilute aqueous potassium bromide and then concentrated aqueous potassium bromide. The ions are same. It is K plus, it is bromide, it is H plus, it is OH. Same. K plus, bromide, H plus, OH. Among K plus is above and H plus is below. So it's H plus, 2H plus, gain 2 electron and H2. Now for bromide and OH, if it is dilute, it's OH. If it is concentrated, it's bromide. What? If it is dilute, then OH. If it is concentrated, then if they are available, they will go. They will lose electron. So how the product will be different? In this case, the 4OH negative lose 4 electron to water and oxygen. In this, 2 bromide lose 2 electron and bromine, orange vapors. What is left? When the H and OH are losing, they're discharged, sorry. So electrolyte is getting what? Water is removed. Electrolyte is getting concentrated. H and OH are leaving. But here, electrolyte, which was initially KBr aqueous, is turning into what? KOH. Why? Because this and this are removed. So KOH is left. Huh? KOH is left. Right? Alkaline solution. I think it is sufficient for today. Right? So first try to understand this whole thing and then do the question. Like, look, first read it 2 or 3 times. You can watch it 2 or 3 times. Then do the question. And I know that you will be able to do up to 80-90% questions, right? And then after this, electroplating is left, and the copper sulfate is very important. We have to do the copper sulfate in detail, the copper sulfate with the graphite electrode and the copper sulfate with copper electrode. These are very important examples. This we are going to do in the next lectures. Okay. Allah Hafiz.